Hello, guys. Welcome to episode 8 of the series where we build a web application using Rust. In a previous episode, we did the final touches to a server implementation and we built the authentication middleware for our CRUD API. Today, I think we'll cover a slightly different aspect. And so, what we want to look today at is containerization. And I think that's a fairly important topic because every application built today is incomplete without being containerizable, because that's what makes your application really portable, and it makes it easy for you to deploy it wherever you wish to. I'll basically be splitting it into two parts. Today we'll focus on the basics of containerization. So we'll be building the Dockerfile, and even with that, we'll be looking at two different ways on how you can build the application, and we'll look at the advantages today. So we'll also try to look at how we can maybe utilize the containers and utilize Docker Compose to leverage sort of like a small local network to get your application up and running. Maybe we'll look at that as well. And in maybe the next episode, we'll also look at how maybe we can get these containerized setup in something like Kubernetes. Without further ado, let's get right into it. So we need to start working on a Dockerfile, and so the most basic thing we can do in order to actually get our application up and running within a container would be, so we will create a container which will base it off of Rust compiler. We'll use the same version we're using locally, just to eliminate any room for issues or incompatibilities. And so all we need to say, okay, we need to declare what is the base image going to be. For us, we stick to Rust as the base image, and we'll specify the version. So one typically nice can mention that Unity for follows is that the language specific containers that are available on Docker Hub, they are tagged appropriately with the same version as that of the actual compiler version, and so that makes it easy for us to just do this. So we'll for the time being, we'll do this. Then what we need to do is we need to copy our code, and rather than just copying it anywhere, the nice thing to do perhaps is to create a work directory. Let's say we'll call it URL mapper rs. If only I can spell it right. And we'll use this as our base directory where we'll keep everything. So now that we have a work directory, what we then want to do is copy over all our stuff. So we say, hey, copy over everything in our current folder to the work directory. Essentially, that's what we say. And once we have copied over everything, what we want to do is obviously compile our code, and for that we will do cargo build. Now cargo build has this flag called release, which basically means that it uses the Rust compiler to compile it, and then the Rust compiler performs a lot of compile time optimizations to this thing, and so that your binary is like really optimal. And so for any production ready application, this is the build that you want to use. And once this is done, we'll set up, okay, what is the port that we want to expose on our container. Then we can just basically specify our command. So it will be /target/release/url/rs. Yeah, this will be our command. And I think I think this is simple enough as a starter Dockerfile. Let's try and build our image then. So we'll be building the URL mapper image. We tag it with the URL mapper rs, and we just build it. So while this is happening, let's talk about a little few things. If you remember our config, we basically set it up to run on development environment by default. It is, I think, definitely preferable to say, hey, env should be probably, let's say, production. And if you were to say this, it will set the environment variable in env to have a value production. Set up the production.json file. And so we'll stick to using, at least for the time being, we'll stick to using the Postgres running on the host machine. And so we will obviously have to do a little bit of work in order to make sure that the container is able to communicate with the host machine. And we'll see how we can do that. And so my database is set up with these credentials running on localhost. Say you are maybe. I think this looks like an appropriate configuration. Port rated with 3000 still. This guy is still compiling. We'll have to compile it once again for the changes to take effect. Especially the game reproduction. Says that it's done. Building the release binary. It took it 3 minutes 19 seconds. Sets up the command and now we're done. And so if you look at the Docker images, you will see that this is our image that was built. The one thing definitely you have to look at and notice is the size of the image, and this is huge. This is ridiculously huge for good reason. I mean, and I think I'll get into the details of why this image is huge and how we can improve that. But let's see this the build that so the image that we've built. Let's get it running and actually see that our application is running. So the few things that we'll have to do in order to run it would be, I'll use the net flag to say, hey, use the host network. And this is done in order to basically, so if you see the development JSON file, which is right now being used, that we are referring to the database at localhost, and in order for the Docker container to be able to talk to localhost Postgres sitting on the host machine, we basically have to say, hey, use the host network. And so once we say that, then we just basically have to say what image to use, and so for that we'll use the tag, and this is it actually. Yeah, let's run it. And so yes, the server has started listening, it says. So we can do, as you can see, our application is up and running. We could also test it via our curl interface. Right now, obviously, yeah, it says key does not exist because we don't really have any data. We can use our authorization, that is good. Because I have not changed the default JSON token, it's still able to use the same authorization. And let's now use this to create our initial data. And first, obviously, I like to do is create GitHub. And so it's going to be github.com/sagar. This looks good. So let's submit this. Looks like it has worked. We again check the API for getting all this thing, and yes, we can confirm that the GitHub URL has indeed been created. And so when we now navigate to /GitHub, it says, hey, yes, we are successfully redirected to. And just to confirm quickly, we can do this on our browser as well. So localhost 3000/GitHub. When we open this, it does redirect us to the GitHub page. Awesome. And so yes, our application is running inside our container. It's able to talk to the database running on the host machine, and we're able to do all the stuff that we've done and that we've set up so far, and we're able to utilize the API to do our stuff. Awesome. Now let's talk a little bit about optimizing our build. As you can see, as we saw, that the image is huge. The image is ridiculously huge. It's like 6 gigs in size. Whereas honestly, if you were to look at just the binary size, it would be like just megabytes, I think. And we could look at it quickly. Let's run a bash on our URL mapper RS image. Okay, so as you can see, and so if we were to say target release, right, this is where our image is, and it is 14 megs in size, and obviously this is 14 megs is nothing. The fact that our image is of almost 6 gigs is ridiculous. We obviously do not need an image of that size. We have the binary. There are two ways typically to do the comparison. One is sort of with dynamic linking, and then the other is with static linking. And the implication is with dynamic linking, the benefits obviously are that your binary sizes would be can be small, but you will dynamically resolve any library, any dependencies that you might have, especially any native or external dependency that you might have. You would have to ensure that whatever environment your binary is running in, that does have those dependencies. So when it comes to packaging and shipping binaries, the preferred approach typically is doing static linking, which means that all the dependencies, everything that is required for the binary to execute is embedded within the binary, which means the binaries, the sizes would might be like a little bit bigger, but the benefits are obviously better because then you can ship it anywhere, and you'll be able to execute and run your application without worrying about those dependencies. So there are two aspects. So one thing is the compilation like I described, and the other thing is the actual binary and running it, right? Now, the tools that we need for compiling a code are the tools that we don't need for running our code or for executing our code, right? As long as we are able to, for example, get a statically compiled binary, then once we have it, we no longer really need any of the rules, no longer need the Rust compiler, we no longer need any of the other tools, basically, right? So which means, this is exactly the use case where we can leverage multi-stage builds utilizing Docker. And what multi-stage builds allows us to do is basically we'll set up one stage where we'll copy our code and then compile our binary over there, and but that we'll use it as a sort of like a temporary stage, and then finally we'll set up our actual image where we'll simply be copying over the binary and maybe some configuration, because we have some configurations as well. So all we'll need is to copy over the configurations and the binary, and then we'll see that the final image size is going to be drastically smaller. It's almost going to be as much as the size of our binary, and that makes a huge difference when you want to distribute your application. Obviously, distributing a 6 gig image versus distributing like maybe a 20 meg image, you can obviously understand the difference, and so we'll look at how to do that. I think there are a lot of articles around this, and I'll maybe add a link to a couple of them within the description down below. So let's do this. So instead of what we just did, we will switch to the multi-stage build, and so we will use the Rust muscle builder as a base image for the builder. So what we need to do is, once we have this as a base image, we now need to, so we copy over the entire code. The only thing we have to do is, in order for us to copy it successfully, let's look up the copy documentation in Docker. Let's look at the copy command. Here it is. And yeah, so this is the one which we utilize. So we will copy over the files, and then we use the chown directive to say that this should be run by the Rust user. This is just specific to the builder image. Now again, so now that we've copied over our files, we will run our cargo build. Yes. Once we have done the successful build, I think now what we can do is we can even build an image from scratch. Let's see what these guys are doing. They're still using Alpine, which is also a good alternative, but I'll go a step further and we'll just use Scratch, and that will help us make the application size, sorry, the image size even smaller. And so we copy over this, we run our build release. And so all we need to do now is copy from our builder the released version. In fact, what you can see already here is the muscle sets up the application in a way that it's in this specific folder slash URL map rs, and I'll copy directly to root, or maybe we'll create a work, or let's create a work, let's create a work directory It's gonna go this. So we copy them. We copy our binary here. Also, we need to copy our config directory. So we'll copy over our config directory because we need the configurations. And then we just basically have to set up our command. rs slash. Yeah. And so let's build this image and see. What I'm going to do, I'll use this as version 2 just to sort of show you the difference between the sizes. You can set up the export. Do I have the image already? Let me just use latest instead of stable. Maybe the yeah, maybe that doesn't exist or something. I think it's typo happens all the time. Yeah, actually we'll have to copy it from this folder. So home six. So because this happens to be the home directory which is already set up inside the Rastaman builder image. Let's not wait because I know it'll fail. No, I think it's very close to done. Okay, so we're copying over the stuff, copying over the config, and voila, I think we're done. So let's first of all, let's look at the images. And as it shouldn't surprise you, but it's amazing to see the fact that the difference between the image sizes is huge. Yeah, the scratch image that we just created ends up being just a little over 13 megs or a little under 14 megs. And so let's try running our this as well. V2, we want to run our V2 image, and also we want to use the host networking for being able to connect to the database. Hey, yeah, so it says it's able to get it up and running. And so let's quickly look at our, yes, we see we can hit this. We see a redirection to the GitHub /key also works. Let's look at the API. Yeah, it all seems to work. Okay, let's see one without authorization just quickly. Great, we get a 401. We saw these two different styles of building images. We saw very clearly how drastically the image sizes can vary depending on which base image you use, and the fact that when we use this multi-stage build, we are able to build a statically compiled binary which we can just directly use without any other dependencies at all. Right, so now let's see maybe how we can utilize our built image with something like Docker Compose. And what this requires us to do is build a Docker Compose YAML file. Yeah, so we'll use the, I think 3 is the one I use, but okay, if it says we'll use 3.9. And then we specify the services. So in our case, we'll have two. Obviously, the first one is going to be DB, and we are going to use Postgres. We'll use the mounted volume. This is for the persistency for our data. Right, this helps. We will set up a Postgres DB, so this will help. This will basically create our database. We'll pre-create a database. We'll set up the user. We'll continue using the ones I was using for my local and password. And then we'll just stick to this. Then we basically will be defining a component for the URL mapper. And then we'll define a build. We're going to just take the let's set up the ports. So in this case, we don't need to use the host networking because we'll basically be utilizing the Docker network, and both these services, the DB as well as the URL mapper RS, are going to be then put on the same network by Docker Compose. And so it's volumes. What we can do actually is we'll set up the environment just to be sure. Yeah, let's just to be sure, because we can override the environment from here. So we'll provide the database URL from here. It's going to be Postgres, and the host, instead of being localhost, is going to be DB, and that'll be provided by the networking. And database name URL mapper prod. Yeah, that's the database name. Which is not there's a typo apparently. Okay, that's what. Cool. So yeah, I think this should be all. So let's try to get it up and running. URL mapper service also seems to be up. Okay. So let's test it. It has been forwarded. Yes. So we do see that the app is ready and is listening. /key GitHub obviously does not exist. That's awesome because we have no data. Let's create our GitHub URL and then we'll go to /key again. And yes, awesome. Great. Now, so we're able to see how we can actually simply utilize Docker Compose to create our network. And this is slightly better because like everything is self-contained, but I think this is more beneficial when you want to automate setting up the development environment for developers. All right. Thank you so much, guys.